In our last episode, we have talked about what is bagging. In this episode, we are going to double click on it and see little more details of bagging. So bagging basically has two concepts. One is bootstrapping, another is aggregation. Bootstrapping meaning, let's say you have training data. Let's say you have 10,000 rows in that data. So what you do in bootstrapping, you take samples from this 10,000 data, let's say samples of 1,000, and give it to each of these models. These samples you can select, take out one row from the training data. Again, randomly you take out one row from the training data. Again, you take out random row from the training data. That is called bootstrapping. So you take samples from a large data set and give to each of the model, right? It's a collection of model, this bagging approach, and you train on each of those samples data. That is called bootstrapping. So we pass all those samples in our ML models like this. When we do a prediction, let's say it's a classification problem. Model 1 says 0, model 2 says 1, model 3 says 1, and model 4 also says 1. So you take majority of these classes. What is that? Class number 1. So that is called aggregation. Why it works? In our last few episodes, we have talked about we need a model which is low bias and low variance. It has to be good on training data as well as on the test data. There is a 1000 of rows which basically disturb the whole ML model. But when you do bootstrap, you're taking sample, right, from this whole training data, and those 1k samples basically they get distributed. Some part of this 1k goes here, some part of it goes here, some part of it goes here, and some part of it goes there. So collectively, the whole data which might have disturbed the model, it distributes among all the models. So the effect is very less. So the variance becomes very low. And that's why the bagging approach works. If you learned something today, save this reel and follow for more such content.